everyone, welcome to tutorial 7, where we will go over the inverse of a 2 by 2 matrix. And more specifically, we will solve for the inverse using its determinant. And determinant is important, and in future videos I will show you how to find the determinant of larger matrices. So first off, I'm going over the determinant of a 2 by 2 matrix. As you can see, I've written a sample matrix A here, where A is size 2 by 2, and it is filled with A, B, C, and D. And to find the determinant, you take A times D minus B times C. And you can see that right here. Now that you know the determinant of the 2 by 2 matrix, you can determine whether or not your matrix is invertible. So first off, if your determinant of the matrix is not equal to 0, that implies that your matrix is invertible. And to find the inverse of the matrix, this is the equation that you would use, where the inverse of this sample matrix A is equal to 1 over the determinant of A, which is solved for before, multiplied by the matrix where A and D swap places, and B and C stay at the same location, but they swap signs. So as you can see here, it becomes D, negative B, negative C, and A. And if your original B was a negative 1, you still swap the sign and make it a positive 1 over here. Now, the second thing to note is that if the determinant of A is equal to 0, that means your matrix A is not invertible. And in a few moments, I will show you 2 examples where we go over whether your matrix is invertible or non-invertible. But for the most part, this set of rules can be seen in a clipping in section 4.4 of your textbook titled Inverting a 2 by 2 Matrix. So here you can see that I've written from section 4.4 of your textbook, example 1, where it asks us to find the inverses of matrix A and matrix B. So first I'll go through matrix A. Now the first step when solving the inverse of a 2 by 2 with the determinant is to find the determinant of your matrix. So the determinant of A is equal to A times D, which in this case is 1 times 4, minus B times C, which in this case is 2 times 3. And here we can see that this means that the determinant A is 4 minus 6, which is equal to negative 2. Now that we know that, we can see that it is unequal to 0, meaning that A is invertible. And since we know it's invertible, we can find the inverse of A. So A inverse is equal to 1 divided by the determinant of A, which in this case is negative 2, multiplied by the matrix where A and D swap places. So in this location here becomes 4, and at the bottom right location becomes 1. And then we also know that B and C, they swap their signs. So instead of 2, it'll be negative 2, and instead of 3, it'll be negative 3. We can solve for it by multiplying each of these values by 1 over negative 2. So that means that our inverse is equal to negative 2, positive 1, positive 3 halves, and negative 1 half. And that is the inverse of A. And we can check our work by taking A times its own inverse, and once you check it, you should be able to get the identity matrix as a result. So we take A, which is 1, 2, 3, 4, multiplied by its inverse, which is negative 2, 1, 3 halves, and negative 1 half. Now we know that this multiplication will work because they're both 2 by 2s, meaning that in the first tutorial, if you remember, you look at the insides and they are equal, meaning that we can go through with this matrix multiplication. Our resulting matrix is a 2 by 2, which you can tell from the outsides. And in this case, for the first value, you get 1 times -2 plus 2 times 3/2. And the second part, you get 1 times 1 plus 2 times -1/2. Down below, you get 3 times -2 plus 4 times 3/2. And on the right side, you get 3 times 1 plus 4 times -1/2. The resulting answer, up here you get -2 plus 3, which gives us 1. On this right side, you get 1 plus -1, which gets us 0. Bottom left, you get -6 plus 6, which gets us 0. And bottom right, you get 3 minus 2 to get us 1. And that is our identity matrix, meaning that we were able to solve correctly for the inverse of matrix A. Now I'll move on to part B of this problem, where it asks us to find the inverse of matrix B. As we know, with this first part A that we've been through, we need to go through and find the determinant of matrix B to determine whether or not it's invertible. So determinant of B is equal to A times D, which is 2 times 6, minus B times C, which is 3 times 4. In this case, we would get 12 minus 12, meaning that the determinant of B is equal to 0. Because it's equal to 0, that means that B is not invertible, meaning that we cannot find the inverse of matrix B. So as you can see, I went through this example to show you how to use the determinant of a 2 by 2 matrix to solve for the inverse of that matrix.